Hello, everyone. Welcome to today's webinar. My name is Terry Ersman. I'm the Chief Marketing Officer for Percona. We're glad to have everyone here. This was one of our most in-demand webinars that we've held yet. So thanks, everyone, for registering tremendous interest. As always, we will record today's webinar, and we'll send a link to you with we'll send you an email within 24 hours with a link to the recording, as well as a link to the slide deck from today's presentation. Before we get started, just want to make sure the sound is acceptable. If you can hear me, if you would please raise your hand in the GoToWebinar window to indicate that you can hear me, I would appreciate it. Great, I see lots of raised hands. Super, thanks everyone. I would request, I'm sure we'll have lots of questions today. Please enter your questions in the questions window in the GoToWebinar control screen, and we'll answer as many questions as we can at the end of the presentation. With that, I would like to introduce Peter Zaitsev. He's the CEO and co-founder of Percona, and Peter will be speaking today on best practices for MySQL indexing. Peter?
Yes, hi, thanks, Terry. And welcome, everyone. First, I will start with saying what you have made a great choice by signing up for this webinar, because the indexing is very important to understand both for developers and DBAs. And I would say that pure indexes is probably the most common problem of various productions issues you can see. And I hope you learn a lot to prevent that. And what is also important about indexing, it is not really that complicated. There are relatively few things you'll need to know to get your indexes in reasonable shape. So what are we going to talk about? Well, I will try to go through three pieces here. First is I'll explain what indexes are and how they work. Then we'll talk about how indexes can be set up for your specific applications, and I will also provide some examples about how we can work around some of MySQL limitations which relate to indexes. First, let me start by talking about the indexes in a nutshell. What indexes really are? Indexes is the data structures which are designed to speed up the access in the database. They also can be used for other purposes such as enforce constraint as unique and foreign keys. But what is very interesting about the indexes is what you can run any queries on the databases without any indexes at all. It will just take a very long time, right? So indexes won't impact your ability to run the query or get the wrong result set. They do impact performance at the same time. You may have heard about the different types of indexes, and I mentioned some on this slide. The majority of the indexes you'll be dealing in MySQL is a B+Tree indexes. And this is the type of indexes I'm going to talk about in the course of this presentation. There are also R3 indexes which are used for working with geographical data in MyISAM, hash indexes which exist in MySQL in tables like memory and NDB storage engines. There are bitmap indexes which many other database technologies support, but which are not presented in MySQL. And there are full-text search indexes which help us to do natural language search, which do exist in MyISAM tables, and they also are planned for MySQL 5.6 for Innodb. When we talk about B+Tree indexes, actually we are not exactly using exact correct terminology. A lot we more refer to the family of indexes which share approximately the same properties, while implementations can be a little bit different. For example, NDB uses T3 for its indexes implementations, while MySQL memory tables use trees called red-black trees. When we look at on these data structures, they tend to have a different structure than in memory, and a lot of the databases use something which is called B+Trees for disk storage, which is different from B+Tree by the fact what the data stored in the leaf node instead of an any node. And I will just give you an example of what it may look like. This is a picture of how the B-tree may look like on the disk. Each of those boxes actually corresponds to the index page, which may be something like 1 to 4 kilobytes MyISAM table and 16K for Innodb. So it will have, of course, a lot more entries than 3 which are displayed here. Now, what you can see, there are branch or root nodes or pages which contains pointers to the other pages for data ranges. Right? And we can see in this case the first range is everything which is less than 3, then everything which is larger than 3 but less than 5, and then the last page is going from 5 forward, which are in this case the lead pages. You can see what the lead pages, they are different by the fact they don't really point to their other lead pages, but they point to the data, right? Which is what we call a data pointer. We also can see what in a lot of B+Tree implementations, there will be the links between the lead pages, which allow us to scan the large ranges without having to go upwards towards the B3 and down again, which improves the database performance. Now, let's talk about what are the differences in indexes between the two most typical MySQL storage engines, MyISAM and Innodb. In MySQL, data pointer actually points to the physical offsets in the MYD or data file. Right? And this makes all the indexes are essentially equivalent. The primary key, which you define unique key, and then non-unique key, in MyISAM, they are all essentially the same from the structure point. In Innodb situation is different. The primary key, being that either explicit primary key which you created or implicit primary key which Innodb has created automatically for you, stores data itself in the lead pages. So in those kind of D1, D5, whatever pointers, there will be actually data in the table stored out there in those pages, not the pointers itself. And then the secondary indexes, they will store primary key information or primary key value as a data pointer instead. Now let's talk and think what kind of operations B-tree indexes can optimize. And there are essentially just two of them. There are point lookups, then we just look up by key equals to certain value, right? And there is also ranges, which can be open range, like everything larger than certain value, or some closed range then between the two values. These can be optimized well using B-tree indexes. This makes them different, for example, from hash indexes, which can only optimize point lookups, right? They are not helpful optimizing for ranges, and this is the reason why, even they are a lot more compact and can be faster, we don't get to use a lot of as many hash indexes, right? Because we have a lot more limited applicability. Now, it is important to understand that certain operations can be optimized with the index. For example, if you say, hey, I want to find all rows where the last digit of the key column is 0. Well, index doesn't provide the good optimization for those kind of operations. We spoke a bit about the integer indexes. What about the strings? Well, what is important for B+Tree index is for order to be defined between the elements. For numbers, we very well understand how it's done. For strings, it also can be defined using something called collation in MySQL. So it can be different between different character set, languages, and so on and so forth. But in the basics, it will be something like examples in the slides, right? There strings are compared in their kind of natural letter order. Now, when you're working with strings, there is also another special type of range which you have to keep in account. This is like with the prefix, which essentially can be converted to a special kind of range, right? The same prefix starting from their lowest possible character value going up to that prefix to the highest possible. And that is the range which index can optimize. That's why B+Tree indexes can be used for prefix lines. If you look at the lines where you have a percentage sign in the front, well, those won't be able to use the index and will require full scans. The same way, you can look at the multiple column indexes. The sort order, once again, have to be defined for them, which is done by comparing the leading column first, then the second, and so on and so forth. In this case, when you look at the index column 1, column 2, column 3, you can see what their first value of 1, 2, 3 is considered to be less than 1, 3, 1, right? Because 2 is smaller than 3. What is important to point out here is that even if you have a multiple column index, we are still going to get the single B+Tree built inside database with just longer data and apply applicable sort order. We're not going to have a separate B+Tree built for every key part. And this is kind of confusion which I have run into a lot in my practice. When we're creating the indexes, it's very important to understand that indexes do not come cheap. There are a lot of overhead out there, so you do want to create the indexes you need, but no more than that. Also, in terms of overhead, typically extending indexes by adding yet another column to the index is less expensive than creating a whole new index, in which we'll talk more in the section about choosing the proper indexes for a system. How the indexes impact the overhead, and how do they impact performance? Well, in two ways. It's both for writes and for reads. For writes, this is their very important piece. You can see updating indexes is really the major cost of database writes. In a lot of cases, you will see majority of cost of writing to the table is actually index updates. But indexes also slow down reads. Which way? Well, indexes will waste space on your disk and also in memory, because a lot of those indexes will have to be brought up to a buffer pool and cached. And also they provide the additional overhead during query execution, because there are more indexes for MySQL Optimizer to consider than it's choose MySQL files. Which items make indexes more or less expensive in terms of costs, right? Well, long primary keys for Innodb. These are pretty bad. Why? Because secondary keys will become a lot longer and slower because of that, right? So try to keep your primary keys for Innodb short. Something like a random primary keys, right, which are inserted in the random order. For example, if you use something like a checksum as a primary key. The problem in this case is that those insertions will cause a lot of the primary key B+Tree splits, which will cause a lot of I/O, as well as make a primary key index very kind of fragmented and inefficient for future access. Longer indexes are generally slower than the shorter ones, and also any kind of indexes, not just primary keys, are slower when you insert data in the random order. Like in this case, if you have something like SSH by password, well, updates and insert are going to be very random, because this hash function is designed exactly to provide that very kind of very uniform distribution over a very large key space. Now, what makes indexes relatively less costly? The indexes which are not very selective are typically less costly to do inserts, because there is just few points where inserts happens. For example, index on something like gender wouldn't be very expensive to maintain in terms of inserts. And also correlated indexes are not very expensive. For example, if you're inserting the data in the table and it has up increment column which just continue incrementing, and at the same time you have some timestamp column, then those columns will grow essentially at the same time, what we call it correlated, and that means there is not going to be a lot of overhead because of that. What is also special about the Innodb tables, which I would expect majority of you use as a main storage engine these days, First of all, the data is clustered by primary key for Innodb tables. What does that mean? Well, that means what the data with the flows, primary key values, will likely to be at the same pages, close to each other. And we can really take advantage of that in optimizations. For example, if you're looking for something like story log comments, right, or something like that, well, we can give the primary key as post ID, comma ID, and that means all the comments for a single post will be stored on one or a few pages, which makes it a lot more efficient to retrieve. In some cases, people don't really like the multiple column primary key because they're not really well supported by a variety of frameworks. In this case, you often can use a trick to pack those together in a single large begin code. Let's say you use first 4 bytes for comment for post ID and the other 4 bytes for post ID, and achieve it this way. Another important thing to know is what the primary key is implicitly appended to all indexes. So when you have a key on the column A being built, actually the primary key ID is appended to that internally as well. And that can be usable for relatively inexpensive sorting, as well as covering index. And we'll talk in more details what that means for down the road. Now let's look at the ways how MySQL can use indexes for optimization. And these are actually 4 different ways. It's optimization to data lookups, it's sorting, it's avoiding reading the data, and also some of the special optimizations. What do we have in terms of data lookups? Let's look at a very simple example here, like we're doing a lookup in employees table by a last name. Well, if you have an index on last name, then instead of doing a full scan, we'll be able to go in index and retrieve, find all the people with the last name of Smith very effectively. It also works with multiple column indexes. If you would have index on department, comma last name, well, then we can very effectively define their people with the last name in, for example, department accounting. Now, when it becomes a bit tricky and where I see a lot of confusion and mistakes being done is when those lookups are integrate the multiple columns. First of all, when you create multiple column indexes, it's the order of column which becomes very, very important. And what you can see here is examples of the cases which are optimized well and which are not optimized. You can see if you have the ranges like b more than 5 or a equals to 5, b more than 6. Those all cases you can see they have the leading columns are compared by equality, or in, which is a very specific list in this case. Those all are going to be able to use the index for all conditions of a very close supply. Now, if you would refer to something like a second or third columns in the multi-column indexes, but not have very closely refer to the first one, then in this case, that index won't be able to use, and the full table scan or other index will be required. And those two, I think, are understood relatively well. Where I see a lot of mistakes and confusion is regarding MySQL not using the index completely, which is a third type. If you would have something like a more than 5 and b equals to 2 case, when you have a range in the first column, and then followed by equality comparison, then MySQL will be able to only use the first key part. It only will use a more than 5 clause using index, and then just filter other stuff after reading the data, which can be a lot more expensive. And the second is essentially a similar example where you can see prefix on a comma b will be used, and then c equals to 2 predicate filter after data is being read. And this is kind of a very important rule of MySQL optimizer to remember. So what MySQL will stop using the key parts in multi-part index as soon as it meets the real range, right? What I mean, more, less, or between. It however will be able to continue using full key parts if you use inclose instead. And that is an important trick to know. The next way MySQL can use indexes is using indexes for sorting. And let's look at this example. Let's select start from players, order by score, essentially finding the top 10 players. If you have an index on the score columns, well, MySQL will be able to retrieve this data very effectively. If you don't have an index, then MySQL will have to do external sort, which is also often referred to as a file sort, which will be the more expensive the larger table becomes, right? And it will sooner or later just stop working. Also, we can often combine using index for lookup to give sorting. For example, we can modify this query to only find the top players for country of United States. And if you have an index on country, score, then MySQL will be able to use index both for lookup and for sorting, which is very helpful. Sorting applies even more restrictions when it comes to getting the efficient sorting. Let's look at the example here. You have an index on the two columns, then all of you cases will be able to use their index on for sorting very efficiently. If you have just a sorting by the first key part, if you are having equality constraint in the first key part and second by the second, if you're sorting by first columns in the same direction, right? Or if you have a range on the column, which is the first key part, at the same time as you sort that column. These all can be optimized using the index pretty well. However, if you try to do something like sorting by the second key part or having the range on the first column and sorting by the second, sort in the different directions, that won't work. And note, unlike in their just using the index for lookup case, the in range doesn't really help us here. If you have an in range in column A and we try to sort it by the column B, well, it won't use an index for sorting and you'll end up with file sort. So what is important here in terms of sorting rules? Well, is what you can sort in different order by two columns. If you need to do that, you'll have to figure out some workarounds. And also you can have only equality comparisons for columns which are not part of the order by. And these have to be leading columns as well, not even inwards. Then let's talk about the third optimization, avoiding reading the data. We mean what all the data needed for a query for a given table can be read through an index. And we call that covering index. What is important to know in this case is that the covering index is not a type of an index. It is just means it applies to a way how index can be used for a given specific query. Right? And here's an example. If I have something like I want to retrieve the statuses for orders for a given customer, I can create an index on customer ID, status. The customer's ID will be used for finding the rows, but then instead of following the data pointer and fetching their status from the data, MySQL can read the status from the index itself, which can be a lot faster. I mean, it can be as much as 100 times faster in some cases, so that is a very powerful optimization. Why is it faster? Well, there are two reasons for that. First of all, especially if your rows are large, then index can be a lot smaller compared to your data size. And that makes it a lot better cached in memory as well. The second reason is if you are accessing the data through the index, then often your data pointers for retrieving the data will be pointing in very different directions and you'll have to do a lot of random I/O to fetch your data. If you're using covering index, chances are you'll have to just have to do an index range scan, which will be in just a couple of index pages, and which will be a lot faster because of that. When we speak about a special optimization, the most important one here is optimization for aggregate functions, namely min, max optimizations. If you have an index on ID, and when you do max ID or min ID from table, then that can be retrieved very effectively without doing a full table scan. Also, you have multiple column indexes you can do where select min or max with a group by, which will be able to use something called loose index scan or so skip scan, which is very efficient. And in this case, you'll see something like using X index for group by in your explain statement. What is important to note here is that this applies only to min and max aggregate functions. It wouldn't be able to optimize like average, right, or anything else for you here because of what the data structure is. Let's talk a little bit about the indexes and joins. The thing you need to know about the MySQL indexes is that the MySQL performs all joins using nested loop methods. And let me explain what that nested loop method is. Let's imagine we have again very simple data schema where we have comments and posts. Let's retry all posts by user after peer and all the comments. What MySQL will do in this case, it will scan the first post tables, finding all rows which have peer as an upper, and that may be indexed, so that may be full table scan, right? Now, what is important was for every such post, MySQL will have to go to the comments tables to fetch all comments which belong to that user ID, right? By this going by post ID index. Now, what is very important here is to have all those joins indexed, because if you don't, then you may end up having the full table scan happening for comments table for each of the rows found in the post table, which can be just insanely slow. What is also important to remember here is what you only need index on the table which is being looked up on. Right? So for example, in this case, for execution of this query, you don't really need the index on post.id because there are no lookups done in this table by this key for this particular query. What you need is in the index on comments.postID because that is by which key lookups have to be happening. And again, let me repeat, is when it comes to the join, you want to have a joins indexes or not happening at all. So if you run into some indexes which you can't figure out some joins, so you can't build the proper indexes for, you may need to redesign your queries or redesign your schema for anything of large enough scale because, well, it just would not scale at all if you don't have your indexes joined. Let's now talk a bit about multiple indexes and how you can use more than one index for the second single table. MySQL can do that, and this is what is often referred to like a index merge in manual or some other literature you would find. So what that is, and let me look at the example. You can have like select from table where A equals to 5 and B equals to 6. Now, MySQL will be able to optimize that query if you have indexes on A and B separately. What it will do, it will go and scan a piece of the index, it will get their data pointers for all row, and it will run intersection on the set, and then go in and fetch the data, which is often better than scanning just one of the indexes. But it is still a lot slower than having the index on those columns contained like A, B. So the key is for end clause, you almost never want MySQL to use index merge. You want to create multiple column index. Now, when it comes to the OR clause, then in this case, two separate indexes is essentially as good as it gets. And this situation is very different because if you have an index on A, B and you have an OR clause, as in this case, then MySQL won't be able to use that index at all for query execution. It will do full table scan. So keep that in mind. Another trick you may want to know with indexes is something called prefix index. What a prefix index is us building the index not on the whole data, but on their leftmost prefix of the character column. And this is an example as you can do it with other tables just specifying the length of index in the brackets. When do we need to use this? Well, first, if you're looking to index any global text columns, you can only build prefix indexes because they just are way too long to be indexed in entirety. But it also may make sense to use index for other data types instead. Why? Because prefix indexes can be considerably smaller in size than full indexes, which can provide substantial performance advantage. Two things to keep in mind about the prefix indexes first is what they can't be used as a cover indexes. So when you create, if you're relying on cover index optimization for your queries, then you have to index the columns fully. And the second piece is when you are choosing a prefix index, it becomes very important to choose the right prefix length for that index. And let me talk a little bit about this. So what is the requirement for a prefix? Well, we want for prefix to be selective enough. And what does selective enough means? Well, that means we want that to be as selective or close to the selectivity of the total column. In this example, we have about 1.5 million of rows in total, and we can see it's almost 1 million of unique distinct titles. And if you look at their first 20 characters as a prefix, we can see what that provides us almost the same level of uniqueness, right? A lot of people think that is enough to say that prefix is good for execution. But that's really not enough, and you have to be looking at one more thing. What you have to be looking at is the outliers, right? Because it's not enough for us to ensure what in average the selectivity remains close by, but what there are, they're not creating a lot of duplicates which have the same prefix, right? And in this case, the things are not really that bad, but you can see the difference. When you look at the most common titles, we can see, well, there are actually 136 movies with the same title, right, which is way off 1.5 rows in average for every single title. But now, if you look at the title, first 20 characters the title, then we have something, well, I don't know what that is, probably some German stuff popping up as a very frequent prefix. And that is what happens in a lot of cases. If you think about their cities, for example, well, probably 4 characters would be very common for, very selected for majority of the cities, but at the same time, there are a lot of cities with prefixes like new and space or sun and space, right? So, which will, these two things up if you just would index a data set of cities with a prefix on your 4 characters. Let's now talk in a little bit details how MySQL chooses the indexes. And what MySQL does is it performs dynamic sample for every query execution. It doesn't just look at where query prepares and plans and then do the stats forever as constant changes. So constants which are in the query, they are very important and the plan will depend a lot on them. What it does then is it estimates number of rows it needs to access for a given table by doing what is called an index dive for estimation. And finally, in some cases when that is impossible, especially some join times, it will have to take a look at the cardinality values to get the average selectivity information. And this is what you can, what analyze table really updates. Now, it's important what MySQL doesn't really just looks at the number of scanned rows and tries to minimize that. It also does a lot of other heuristics, and in some cases in the optimizer code, you can see like a plain hacks to make it behave certain ways in certain conditions. It has to do things like treating the primary key as a special for Unionizing because it has a completely different call structure for lookups. It has to consider the benefits of using covering index. It has to consider what the full table scan actually can be faster in some cases when large range snaps, right? It also will consider wherever you can also get a benefit for the same index for sorting, right, or something else. So what do you need to know with all this kind of complexity? Well, first you shouldn't guess. I mean, in a lot of cases, you may guess how MySQL is likely to optimize the query and execute it, which will make sense. But I will urge you to check and verify what that is actually happening, because you may be missing something, or MySQL may be missing something and have some different ideas. And then also know that that's not enough to just run one query for a single set of constants to know how it's going to be actually optimized. In your production, there are other chances that you are going to meet different execution plans. And this is where you can use the tools from Percona Toolkit as a PT query digest to regularly analyze your queries to understand how they execute. So I mentioned in a few cases, okay guys, check how your queries are executed. Well, how exactly do we do that? And we do that exactly by looking at the Explain. Explain is pretty well documented in MySQL manual, and frankly, talking about Explain itself will take a whole this hour if I would do it in any reasonable level of detail. So I just want you to documentation with note one of the things is what Explain really provides the estimates about how query can be executed. The real query execution can be a little bit different when it was slide, so keep that in account. And I have provided here the slides the Explain example, and I will talk a little bit on some of those pieces as the most important things to consider. First, you want to look at the type column. And in this case, you can have all kind of different types of data access, and I would say they range from system and cons, which are essentially the fastest access types for the table, to something like all, which is full table scanner, which is likely to be the slowest one. You also want to note the rows, and this is the amount of rows MySQL expects to scan in this table. The higher it is, obviously, the more costly a full query like to be. Very often one would like to pay attention to the key length. And why? Well, because that helps us to understand how many key parts MySQL is actually able to use. In many cases, you'll find that MySQL is using less key parts than you would expect it to use, right? And that is a cause of performance problems. Finally, you want to watch for extra, which can contain some things like user index, which is essentially using covering index, which is good for query performance, or using temporary or file sort, which is an additional types MySQL have to take during the execution, which are bad for performance. Let's now talk a little bit how we can apply those knowledge as our indexing strategy for your specific application. So first, I would say you want to take a look at your performance critical queries and look at them kind of all together. Don't just try to build the indexes for one and then another and so on and so forth, because in this case you may end up having a lot more indexes than you would otherwise need. What your goal should be in this case is to ensure all where clauses and drawing clauses kind of in direction of the lookups are indexed, are using indexes for lookups, right? Or at least the most selective parts are. And by the most selective parts are, I mean, it's what getting the additional filtering done for indexes doesn't really minimize the number of rows or the system has to rows. Now, generally, you want to extend index if you can, as we spoke, instead of creating the new index. And what is also very important is what you want to validate the impact of your performance as you move along, adding the new indexes for new query types and so on and so forth, because often adding the indexes or changing the index structure, you can have some unanticipated consequences which can impact your performance. Again, looking at the output of PT, analyzing the queries of PT query digest with Percona Toolkit is a very good approach to use. Let's look at an example. And let's say we have two queries selected from the table, one by equality constraint, the two columns, and the other range. In this case, by looking at those two queries at once, you can actually see and say, oh, key in the order B, A is actually better for such query mix, right? Because it can resolve the first query and it's also able to use both key parts for the second query. If you wouldn't be looking at the query set at the same time, you may have chosen index A, B for the first query, and then you'll have to add another index for the second query to to benefit from that. Now, if you have everything equal from the column order standpoint, you often want to put the most selective keyword first. That will make the index access faster. And also important thing here is if there are some queries which you don't really run frequently and which are not performance critical, you may not want to index them. Maybe if you run some reports, which is just once a month, it may be fine for them to have a full table scan, right? Maybe you run them on the slave or do something else instead of creating their insane amount of indexes which slow down all your operation. Finally, let me go about some tricks about what can help you to deal with MySQL limitation. And the trick number one, which I use probably the most commonly, is what I would call enumerating ranges. In this case, we can see we have an index on A, B, which will exist in database or wherever, right? And we have a query which has a range on column A and then equality to column B. As I spoke about that won't be able to use this index effectively. It will only be able to use keyword on A. But at the same time, because the between range is small, we can actually convert that in our application to be a list of items in the inflows, like 2, 3, and 4, and be right. And in this case, you will be able to use both keywords and run it very much faster. There are also various combinations for these techniques to deal with a little bit larger ranges if you need to. Another, which is, I would say, an extension of this technique, is adding a fake filter altogether. And let's look again at the given index, which is gender and city, and the query, which says, well, find everybody from city New York. Well, if you happen to have this index and this query, you won't be able to use index at all because we don't have any reference to the first column. But if we extend that and then we specify the gender actually with all values which can be in that column, together with city New York, we don't really change any meaningful in this of this query. There is no any filtering really going on here, but it will be able to use the index well. Now, to note, of course, that this index, this trick works best for low selectivity columns. Like you have something like gender, some sort of status, maybe some Boolean types, day of the week, or something like that. Where it's easy enough to at least all of those items here. The frequent trick number 3 is unionizing Filesort. And as we spoke before, really sorting by the index can be very restricted. So very frequently you have a query where you have to have in clause on the column while sorted by something. And it's very kind of nasty with that blocks our ability to use file to use sorting. What you can use in this case though is you can convert that to a union. We can fetch the top first top 5 items for A equals to 1, right, and then first 5 items for A equals to 2, and then do a union on those and do it order by, right? In this case, you will have an ugly plan shown by Explain, and you will even see a file sort out there, but that will be very small file sort over just a few rows, right? Just 10 rows in this point. And such query modification, even if it becomes larger and looks more complicated, it can be 10, so even like 100 times faster than original queries because it can use index for store. Okay, before I end, let me point out to some other items if you are looking to learn more about the MySQL. First, we continue in our webinars. The sessions, there are 2 webinars which are scheduled right now, and we are adding 2 more webinars next very frequently. So check back to us, and there is some very good webinars coming up online. If you would like to learn even more about the MySQL, consider joining us for the conferences. We have 3 great conferences already scheduled. One is in New York in October. Another is in December in London, and our biggest event of the year will take place in April 2013 in Santa Clara. Finally, if you're looking for some very in-depth coaching on specific topics, consider Percona training. We have lots of great locations scheduled now, both across Europe and United States, and we are also starting their online learning initiative for training. Please check that out. Well, thank you, and that's it for me. And now we'll be able to take some questions.
Okay, thank you, Peter. Again, if you have questions, please submit them through the questions panel in the GoToWebinar control screen, and we'll get to as many of those as we can. So let's see, first question we have here, Peter. One developer on our team wants to replace longish 25 to 30 indexed bar characters with an additional big int column containing the CRC64 and change the indexing to be on that column. This is going to save indexing space. Is this a reasonable performance?
Oh, yeah. Yes, I think that is a very good trick you mentioned. I just didn't have the time kind of to go over that. So as I mentioned, MySQL doesn't have a hash indexes. But at the same time, you can actually build something very close to hash indexes when you build your hash manual like CRC32 or some 64-bit functions, right, or of a character field or some other long combination. And then you can do your get the lookups a lot faster. Right? And that can be indeed substantial savings in a space where index can sue and improve performance a lot. Well, I would say two things that you have to consider in this case is make sure you don't forget to update those like CRC or something. Then you update your table, use triggers or do application, because that is where a lot of application bugs can come out if you forget to do that. And also note whatever checksum you're using, if it's 32-bit or 64 bits, well, those checksums will have some collisions. So when you do a lookup by this type of hash key, you also need to add another clause, right, to check the string in question matches what you're looking at as well.
Okay. Next question. In regards to extending an index being better than adding a new one, let's say I have a table named PO that has a primary key of PO pound and two additional fields for vendor ID and order ID. If I have an index on vendor ID or order ID, but my query is only selecting on vendor, will the index have any impact on the speed of the query?
Yeah, well, that is a good question, right? So in this case, when you have an index on vendor and you're adding something as vendor ID, order ID, you will increase your index size a little bit, right? I mean, I would expect that will be something, maybe 10% for Innodb tables because of all the additional information which is stored in the indexes for Innodb tables, right? So you will have a little bit slow down compared to key on index on vendor itself, but it will be still a lot faster compared to, for example, having index on vendor and then another index on vendor, order ID, right? Because that is what people do in many cases. They figure out, oh, this is a new query where I need a lookup on vendor and order at the same time. Let me add the index. So my one kind of query will only use the index on vendor and other use the index on vendor and order. This doesn't make sense in majority of cases. There are some exceptions, but they're very rare.
Okay, next question. How many indexes is too many?
Well, that's a good question. How many indexes is too many? It depends on your performance needs, right? Wherever you have any problems with writes or not, right, or anything like that. There are some MySQL limitations, right, about how many indexes you are able to create. I think that was around 64 those days, but really it depends on your application.
Okay. Let's see. In trick number 1, will where a in2-4 be worse than where in 2, 3, 4?
Well, this is so well in this case, what you use for ranges, right? In MySQL, you need to use this specific form that actually lists in all values, right? You can't use dash, right, in the in column, right? And that makes especially sense, right? A lot of people think like, oh, why MySQL doesn't do this conversion on itself? And it's kind of easy enough for integers, but if you think about a more elaborate data types like strings and so on and so forth, right? Or then in general, conversion from ranges to in list can be extremely complicated. But I think my main point is you want to use the in and list inheritance instead of.
Okay, next question. In which cases should auto increment be used as a primary key?
The after increment as a primary key is a very good default choice. So if you don't have any specific reason to use something else as a key, then use after increment, especially when you're speaking about the Innodb. Having primary key is a lot better than not having one, because Innodb will still create a primary key and it will just create some hidden column which you don't have any way to access and benefit from. And I would only go to having after increment primary key if you have some maybe very good natural keys in that table, or if you want to have something, as I mentioned, in terms of data cluster optimization or something like that.
Okay, is the B+Tree Innodb index a single or double linked list at the leaf nodes?
Okay. Any more questions, Terry?
Yes, Peter. Can you hear me?
Yes, yeah, I can hear you.
Okay, the next question was, is the B+Tree Innodb index a single or double linked list at the leaf nodes?
Yeah. Well, that's a good question. So so if I remember correctly, that is their yeah. I think that was a double list, but I'm not don't remember from the top of my head.
Okay. Next question. You mentioned avoiding indexing for queries that are run infrequently or run them on a slave. Is it possible to implement different indexing on a slave specifically for such queries?
Yes, that is one of the kind of advanced replication techniques you can use. You can define different indexes on the slave to have it optimized for your reporting queries compared to their normal your normal production index. MySQL replication support that.
Okay. Next question. What is the impact on indexing to use a wider UUID, such as varchar 36, instead of auto increment?
Well, if you use UUID, right, you generally get their a lot longer indexes. And I would say their UUID, they're kind of not exactly completely random, but they are also have a stable locality as after increment indexes. In terms of performance loss, right, because of using that, it can vary, right? And I would suggest to really take a look at the benchmark at the application. As a general guidance there, if you have a lot of indexes, then a lot of secondary indexes, then the impact will be greater. And also the impact is greater for tables with shorter rows, right? Because if you just have a couple of columns to carry, then using long worker instead of 4-byte up increment, that's significant data increase, size increase.
Okay, next question. In the case of a junction table, would indexing on foreign key 1, foreign key, comma, foreign key 2, and on foreign key 2, comma, foreign key 1 be a good idea?
Well, yeah. I mean, in some cases when you have this two tables or tables to facilitate many-to-many relationships, you essentially would go through the table in both ways, right? And then even more so, having the indexes go in both directions with the same set of columns help us to use the covering indexes for queries kind of go in both ways, which can be very good for performance.
Okay, next question. How does an index, how could an index be used having an index on one column and using order by on another column? We need to add the index on column using order by clause?
Okay, so in this case, what you have to, using index of order by, for order by reconciliation, this is limited, right, as I try to explain. So if you can't in the same table use one index for selection and the other for order by. It has to be the same index. And also it only works in very specific cases, like you would have to have, for example, equality comparison on the first key part of the index and an order by on the second key part, or something like that in order for it to work.
Okay, next question. Are there any special concerns or tricks for selecting using some date ranges or between dates or after a date?
Well, I would say with dates, one of the tricks you should know is exactly this date in the ranges, right, for dates. We have been very successful using that in many cases when you have also a lot of other clauses. Why? Because in a lot of cases you want you have a lot of queries where you would specify date, range, and some other conditions which kind of motivate you to put the data in the leading portion of the index. One of the tricks what I have been using that is having something as what I call as a dates table, where I would have a table which essentially will contain all the dates for the next 10 years, right, or whatever time frame the application is. When what I can do in this case is I can use that table to generate the ranges. I can, right? For example, I can say, well, I will create this table for everything between January 1st and March 2nd, and then I join that table to my original fact table, right, with other clauses added. In this case, that will be essentially close to the tick number 1, but we are using the join to our table instead of creating the large in clause. And that essentially works best if you have a large amount of items, maybe a few hundreds, which would be very inconvenient to manually create the query.
Okay, very good. Looks like that's all the time we have for today. So we'll send an email to everyone who registered with a link to a recording of today's presentation as well as to the slide deck. In addition, we'll take all the questions that were asked, and Peter will review those and post a blog answering some more of the questions on the on MySQLPerformanceBlog.com. We did have more questions than we could get to today, unfortunately, but we will answer as many of those as we can. Thanks for your attention today. Look for the email within 24 hours with the links to the recording and the presentation. And thank you, Peter, for today's webinar.
You're welcome. Thank you. Thank you, everyone.